All right, guys. So we have this over here on the left. We showed the derivative of e to the x is just e to the x. So let's take one that's slightly different. If we have, I do not mind. Go ahead. Alright guys. Alright, so we have the derivative of, say, e to the 3x. Think about what would that be. So if we go by the same formula, it tells the derivative of any constant to u, where so u is some differentiable function of x. Let's see what we get here. Well, we still write e to the 3x times the ln of e times du dx. So derivative of 3x with respect to x is going to be 3. So this would be equal to, this is 1, so 3e to the 3x. So this is a good problem here. So the d over dx is the derivative of this guy with respect to x.
Just the x. Okay.
No, this here?
No, the du over dx is the derivative of the x.
Oh yeah, du over dx is the derivative of this with respect to x. Yep. Mm-hmm.
So it's 3e3x.
So the derivative with respect to x of e to the power of 3x is 3e to 3x. Now you've seen two examples, one where it's e to the x and one where you have e to 3x. And you probably notice a pattern here. If you kept doing this one, if you took the second derivative, it'd be
it would keep being
9
multiplied by 3.
Yeah, 9 e to 3x, 27 e to 3x. You keep going. You don't go too far, that's right.
72.
Okay. So,
Wait, can we go back? 72 goes to stack or stack rock.
yes.
It was ln e times d. Why is it 3 not 1? Because it winds up being, it's d3x over dx, which gives you 3d.
The last part here?
Yeah.
Yeah, so the derivative of 3x with respect to x is just 3. You can technically do power rule, 1 in the front, drop it down. So, with this packet, would anyone like to see guys, would anyone like to see a problem from the packet?
Oh, we need to do the second.
Not packet, sorry, the sheet, the implicit differentiation.
No, listen, we need to do the second.
I agree with you. We should definitely look at one of those. So let's go ahead and do that now.
And then we might want to do the one to the side.
Yeah, we should do this. No, we should do this.
I don't think so. Yeah.
Did we do 13 yet?
I did it. No, I thought I said yes.
I don't get it.
Wait, no, we don't have it.
Yeah, we did it.
So this is 13. This is from the implicit differentiation
Oh,
worksheet.
it's not the one I did in 13. Oh, Lord. No.
So for 13 we have 4y squared plus 2 equals 3x squared. Alright. So number 13 says to go ahead and for each problem use implicit differentiation to find the second derivative in terms of x and y with respect to x. So yeah, we are gonna find one at a time.
You can't do 5 at a time?
So implicitly, I cannot. Alright, so this here we have the derivative of this with respect to x would be, we have 8 y dy dx plus 0 is equal to 6x. You could write dx, but eventually, I think now you're at a point where, okay, if I do something that involves a y, I'll write dy dx, otherwise I won't write anything. We've seen how it works out.
So dy dx equals 6x over 8y.
Right. And then you can just simplify it.
Oh, yeah. And then the next one is d2y over dx2.
You did it with global rule. Oh, no, that's stupid. You could. Bowman teaches to just move it to the top.
Move it to the top.
Isn't that
Excuse me.
You can do it.
We never learned equation rules because she taught us to always do right.
Yeah.
Wow.
Well, we never really did.
Yeah, I was like,
Oh,
oh,
yeah,
yeah,
yeah.
we're like, excuse you?
Alrighty.
So we got
So we got the first derivative. Now we're going to go on and find the second derivative.
do it again.
So, let's go ahead and select all.
It's the bottom
Oh, shit.
the top.
Okay, so yeah, how do we do that?
So now let's go ahead and let's take the derivative of this. So let's take d dx of dy dx is equal to the derivative with respect to x of 3x over 4y. So this here, you can see the notation that they use in on the sheet. They have d squared y over dx squared. Don't let it bother you that it's, why is it not d squared x squared? Don't let it bother you. Dx is one thing as together. It needs to be like as
Why
one.
did you write it?
It's just d over dx and then you just add the y's. That makes sense.
Yeah, so I'm taking the derivative of
But
this
you have
with respect to
d2y
x.
over dx.
So if you go straight across,
That's just-
it's like, okay, the second derivative of y with respect to change in x. Okay. Just don't let it bother you. Don't let it concern you. It just means the second derivative with respect to x. That's all it means.
Are you freaking kidding us?
So if we do this, if I do the derivative of this, quotient rule says derivative of the top, leave the bottom alone, minus leave the top alone. The derivative of the bottom would be 4 dy dx,
I wrote times.
all over the bottom squared.
I was gonna cancel everything. Wait, the dy dx. Oh shoot, I forgot about that part. I'm on my shoes.
And if we simplify this, this would be equal to, we have 12y minus 12x dy dx all over what would be 16y squared. And we know what dy dx is, so we want to definitely write our second derivative just in terms of x and y. So we're going to plug this in instead of dy dx.
Okay. Oh, I'm getting you slowly but surely.
Okay,
So if we plug that in, you'd have 3x over 4y times 12x.
Now what if it gets it an improper? What do you call it?
So if you simplify that, I'll go and plug it in as it is now. So we have 12, sorry for saying right away, minus 12x times 3x over 4y all over 16y squared.
I'm sorry.
You.
So what's 16 divided by?
Well, how do you do simple math?
Okay, so when you're multiplying fractions, you can write this over 1 if that helps. So you have 12y minus, if you put 12x over 1, 3x over 4y, all over 16y squared.
What if you simplify that first?
What's that?
Like divide that by 4 before you do all that.
Yeah, so that's where we're going at. So we're going to go ahead and simplify this. So I wrote it as over 1, so now you can see how you can simplify diagonally or up and down before you go across. So if you look at 12 and 4, they both have 4 in common. So this becomes a 1, this becomes a 3. So if we continue that over here, we would have 12y. If we go straight across, we have 3x times 3x, which is 9x squared, so minus 9x squared all over 16y squared. Sorry, over y. Whoops. Forgot. Here we had 9x squared over y. And then these you can put together if you imagine that their LCD is y. This is the same thing as 12y squared over y minus 9x squared over y all over 16y squared. So you now combine these and you have 12y squared minus 9x squared all over y all over 16y squared. So I'm just combining these fractions.
Don't you not want the complex fractions?
Correct. So I'm making it so it's a single fraction where it's over a single fraction or not a fraction. And then now I can just say, okay, so to divide by this thing is multiply by 1 over it. So I'd love to fit this on one thing.
Too many numbers, too many lines.
So you definitely, your algebra needs to be on par. So if this is confusing, you definitely need to soak it in and make sure that it's solidified in your mind. This is just adding fractions and simplifying complex fractions.
What is your number? That's 12y squared.
12y squared minus 9x squared over y all over 16y squared. Do you have any questions about where we are now?
Why is it dark? No, you're not dark. Right. Where did this 12y squared over y come from?
That came from me wanting to combine these as one fraction. So I looked at, okay, this is like 12y over 1. So the least common denominator of these two is y. So I went and multiplied the top and the bottom by y to get 12y squared over y. So I can put them together as one.
Okay, so what's the next step if we don't want to do the fraction?
So the next step, I have weights.
Okay, yeah.
Are we good? We have 12y squared minus 9x squared over y. All over 16y squared. That's a weird looking line.
Yeah. And when I figured that out, I figured out like, I don't know, like 8th grade, really late. And I was like, oh my god. Technically it should be double B. But like if you look at like the certificates in Spanish or German, it's a double B. So it's like, yeah. What am I saying? Like something in life makes sense.
Was kindergarten, I was going, I felt out. I was excited. I thought it was the coolest thing.
Yeah, the silence. Yeah, I was like, whoa. So what did you do when you got to like psychology? Were you like, oh my god. By then it was just the novelty wore off.
But not.
Right, to divide by a number of things multiplied by reciprocal, so we have this, and then finally we have 12y squared minus 9x squared all over 16y cubed.
Oh, cute.
So this would be,
This is so extra.
So I got this, except I got minus 3x instead of minus 9x squared.
Wait, if you're multiplying the reciprocal, wouldn't it be 16y squared?
What day
what's that?
What day is that? Oh yeah, the 16y should be on top. No, it's that fraction, top fraction is over 16y squared over 1. And then you switch it to 1 over 16y squared. What?
The over 1 is implied. It's 16y squared over 1 on the bottom.
Wait, so that's essentially multiply.
Oh, I see. So you are
I know,
multiplying.
but like it's all under the bottom.
It's top fraction divided by bottom fraction.
So the
Yeah,
main
it's just
fraction.
so bottom one is the bottom one. It's the fraction.
This is the main fraction bar here. So if this whole value is being divided by 16y squared, it's the same thing as saying, Mackenzie, this whole value times the reciprocal of this. To divide by a number since multiplying by its reciprocal.
I think I got you. 3?
I don't know how. Can you just look at these really quick and tell me what I did wrong? And I ended up with minus 3x instead of minus 9x. Like, I wrote it here. Today's
Yes, but definitely it's a little mistake probably made somewhere. Yeah.
16 times 4.
I'm not sure. Somewhere though. I can go back. Well, I can go back here and probably find it.
No, I didn't do the same thing as you.
So even if you don't do the same exact process, you should arrive at the same
I know,
value.
that's why I'm confused.
This should be done.
I'm sure you can find it as long as you're careful. If you still can't find it in a little bit, let me know. I'll look for it. That is 13. 14 would probably solve in a similar fashion. And then, so I'm going to let you guys go ahead for your homework if you haven't finished it already. If you just finish this worksheet, and it'll help you study for the quiz tomorrow. So what I'd like to do for the remainder is look at the other part of the quiz, which is going to be derivatives of exponential and log functions. Just some examples of those.
3x times 4, so it should be 3, just 12, minus 12, x, and that's going to change.
That's a good question.
Knowing that I did my algebra correctly, that is good.
What do you think I should do?
Got it on Friday.
Okay. I will provide it. I will provide it. Thank you. I do.
You want to do other letters that are not X and Y?
Those are words.
Okay, that's fine. Let's do fine. The one I said first. That's fine. Okay, that's fine too. That's tomorrow.
Okay, I'm going to move the 5.
All right.
It's just 0.
All right, guys. If you're ready, we can go ahead and look at some other problems that are going to be on the quiz.
Wait.
Okay.
We have a quiz tomorrow.
Are you guys ready?
Okay, I guess so.
Are you guys ready to look at some problems? Okay. Okay, so let's say you have, we already looked at ones like number 1 and 2. Let's go ahead and just skip to something like number 8. This is on page 178. And we have y is equal to x squared e to the x minus x e to the x.
Okay, wait, I have a question.
Yes.
What is the facing the other way? What's my question? Oh, are we going to get this equation on the thingy, or do we have to remember it?
All right, so Hope already asked this question, and so I'm going to repeat myself, is that yes, I will provide the formula.
Okay.
Do you treat it like product mode, that first one? So, oh wait, this is all, what?
It'd be changed.
All right, so would anyone like to come on the board and do this one?
No, it's
Go for it. Go for it.
I'm still laughing at your thing.
What?
I'm still laughing at Negro thing.
Where the heck did you say? I was like, oh, what?
Alright,
You
so
were
for
gonna
the
say
formulas,
that.
here you go.
That's what it is.
Right there.
Let's just say that out loud. Yeah, exactly. So it's just about it's just e to the x, remember? It's just e to the x. We just did that for about like again in the US.
Yeah.
Just to murder you.
So this was gonna take a And I was thinking through all
That was really accurate.
to do.
I hate all of you.
Can we just write derivative e to the x and just assume that it's e to the x?
What's that?
From now on.
I'm just writing it out so that I know.
Two.
Yeah, yeah, that's fine.
You forgot your square on the negative e over dx. Sorry, I'm not trying to read. Do you see that? What I'm writing my goes through d over dx of x, but it should be x squared.
Okay.
You see that? Yeah, I just wanted to point that out.
Sorry, I'm not thinking.
No, no, no,
Yeah, I
that's
was
fine.
like, I don't think I want to forget to actually derive that. Is that the word you use? Derive it?
No,
It's different. It's differential.
The x. Oh, it's one. Yeah, but derivative of derivative. The x is derivative.
No, isn't it?
It's either way, it's the I don't think it matters.
Oh, yeah, it does
No,
matter.
with product rule, it doesn't. You know what I mean, like when you put it together, is it e to the x to the x or is it x to the e to the x? Either way.
What are you saying for real?
If you do 4 times away, it's the same thing as x squared. No, remember the r. You have to multiply.
Hey, treat everyone with respect. It's number 2 on the board.
There's 3 on the board. You're not respecting them. Shut the fuck up. See the best thing. I think it's what I'm confused on where you're actually e times x to the x. Or is it x to the x? You're gonna x to the x, right? Or is it x times e to the x?
Don't forget your parentheses.
That's what I'm asking. How would you say e to the x to the x?
Each of the x. The x
Okay,
You're doing well so far, this guy.
I found it equal to 1 and 2. Really? No, it doesn't.
Oh.
Extra. Can you add I don't think we would get to e to the x times
That's our like term.
dx over dx plus 1. Which is 1. So it's this right here is the product part of this. You should just leave it the way you said that first part. Wait. I did everything.
We have to.
Right? You should have to do it. I like wanted to write it out. 25. So the derivative of e to the x is e to the x.
Oh my god,
That's so do we have one right? It's minus.
It's minus this whole thing, so between the negatives, so that we know. So it'd be more like plus this.
So then it turns into 8 to the x squared times 1.
Yes, be careful.
That's great. That's great.
Did you find it yet?
No, I just got a bigger number.
You're like 800
Yeah.
y over 1,000 y cubed.
I don't even have numbers.
No, this is 14.
Oh.
That's good, so let's go over this. Thank you so much. Awesome. Fantastic. Good job. All right, so for here we have y is equal to what we see in black. So we have product rule going on here, and we have product rule going on here. So product rule says the derivative of the first, or you can do derivative of the second, that's fine. I always say derivative of the first, leave the second alone, plus leave the first alone, derivative of the second, but this is also fine. So Harris did derivative of the second, leave the first alone, plus leave the second alone, derivative of the first one. That's correct for product rule. Minus, if we do product rule over here, yeah, so minus now product rule of x e to the x. That would be leave the first one alone, derivative of the second, plus leave the second one alone, derivative of the first part. Okay, that's good. And then so going through here, the derivative of e to the x is e to the x. The derivative of x squared is 2x. The derivative of e to the x is e to the x, and the derivative of x is 1. So it's a matter of simplifying here.
Get to the last, like, from the second to last, second to last. That's wrong.
Am I explaining that well so far?
Yeah.
Okay.
Yeah, that's what it's turned. Yeah.
Okay. So we have this minus this. So now we go ahead and it looks like he went ahead and wrote this a little cleaner. Just drop the multiplication signs. Okay, x squared e to the x plus those two together. Just put a 2x in the front. It looks a little nicer. 2x e to the x. Now we change minus to addition, and to do that you distribute the negative. It's kind of tough to see, but there's a minus sign here. So we have, that's technically going on, minus x e to the x plus distribute the negative, negative e to the power of x. So distribute the negative. And then combine like terms. Looks like we have an e to the x term that has an x squared in front of it, so that doesn't really have anything alike with it. But if you look here, we have 2x e to the x plus negative x e to the x. Well, 2x of something minus x of something would be 1x of that something. And then this here just minus e to the power of x.
Okay.
So this would be, this is y prime. Or dy dx. Or dy dx, yeah. This is a more complicated one. I won't have, if I have one of these or this complicated, it won't be one of them. So you'll see something more like number 1 or number 2 or 3 or 4. But around number 8, number 7 starts to get a little more complicated. But as long as you guys are careful, you should get these. You know, the derivative of e to the x is e to the x. And I will provide the formulas. So let's look at number 11.
Wait, can you wait?
Yeah.
Plus. We can move on. Thank you for
Okay.
waiting.
All right. So then, if you look at something like number 11.
Like, I would see something like that and think, oh, that's too complicated, I got it wrong. Like,
You
I
gotta
really
have
like that process would be.
a little faith in yourself. I know that it's a lot of work sometimes, but as long as you're careful, you should be correct.
Is that it? Just find the root. I'm okay with that.
So find dy dx. So dy dx would be equal to, according to our formula, the derivative of a to the u is a to the u ln of a du dx. So this would be equal to, go ahead.
Is in the exponential period. That's when you have to use exponential functions. But if it was like x to the 8th, then you would use product rule.
Yeah, so for x to the 8th would just be a simple power rule,
Yeah,
or
that's
chain
right.
rule, yeah.
So it's x to the 8th when
So 8 to the power of x times the ln of 8
How do you find the element?
times the ln of 8
Yeah.
times the derivative of x,
You don't have to find it.
the derivative of x dx, which is just 1. So this becomes, and they write it the way that they should,
So it's just 8x for the element of 8.
8 to the power of x ln of 8. Yeah. And you can leave it as ln of 8, because this is going to be some irrational value. Yes. Yes.
So I was like trying to do number 14 on the paper, and I was looking back at our work for 13.
Mhm.
And I don't know what you can want them. Because I don't know
Yeah,
how
that's
something
the one
got
where I got 1,000 wires to use on the bottom.
I know how something completely specific paper, because I'm not sure how something got where.
Yes. Let me write on here, guys. You guys should have studied natural log in the pre-calc. Is that not something that was touched on? So if I have, let's say, ln of a, that's equal to the natural log of base e of a. That's all natural. Natural log is log of base e. That's why you can apply the formula that we've been applying.
There's an X right here. Hold on, I can answer your question on that.
So why would you go?
So, when we simplified this, there's an X right there and an X right there.
So you didn't get
So
1,000
it would
of them?
be 9X.
So Gross, why is that relevant to
Because you have to know the derivative of, the derivative of exponential functions, which is what this is. This here, I would just point out, like, what is ln? What does that
So if
mean?
we wanted to rewrite that, it would be 8x times the log base e of 8. So we're,
I mean, you could. I wanted everyone to know, make sure everyone knows what ln means.
oh, okay. So I in ln in my phone, I put it as natural log instead of.
Oh my God. I think of Ellen the person and then I believe Ellen.
Just putting it out there, that's, yeah, math humor.
I know every math.
Wait, so then it's 5.
We're lazy.
Poland calls it natural log.
We should do it.
What is natural log like to It's probably so weird.
This should just be 1 over x.
I can get wait, what's negative 20 minus 16?
This is one of those specific ones that works out real simple.
Wait, how do you do that?
So this is one of the ones that works real simple. So if you were to apply the formula on page 175, it would simplify here. Just like if you did the derivative of e to the x and you did the whole formula, it would simplify to e to the x that we did for the warm-up. So this is one that you should know, that derivative of ln of x is 1 over x. So this is the formula on page 175. How to take the derivative of log functions.
I don't know where am I wrong.
Yep. Yes. Yes.
Why is this guy? The natural log oh, I missed the blitz. Yeah, literally. I was like, oh, I missed the 0. Oh,